can see me. Yeah, I think I want to watch some of it back because I was a bit confused. Also, I guess okay, chat. Okay. Do want to go back a little bit because I think I fell asleep.
We don't care about this because we are not using a palletized buffer. Like I said before, colors much later in the series, but for now, you are all very familiar with that. Well, that is what this is. So if you want to make a back buffer that is basically colors specified in that fashion, where every individual pixel has an RGB value, then you want to pass this, and that is what we're going to do. So we are going to put that in there.
Do I have to go back all the way?
I am going to go ahead and get that out, and that will give us, just like we did down here, that will give us our width and our height. So basically we can just subtract the right from the left and the...
What's paint?
top from the bottom, sorry, the left from the right and the top from the bottom, saying that correctly, we are going to go ahead and do that to produce the width and the height of the buffer that we need to fill the whole window. That's basically how big we will need it to be. So we're going to go ahead and call resize div section, and excuse me, we are going to pass it that width and that height. So in here, we are going to get a width and a height, and we will basically need to build that buffer using Windows to give us a buffer that we can draw into. Then what we will do, once we have our div section sized properly, we will actually in Paint, instead of calling this patblit thing here, which is not really anything that we want to do, we will do the begin paint, and we will use the rectangle that it passes us to basically update that rectangle with whatever the contents of our buffer was. So we're basically going to create a buffer in WM size, because we always get that anytime the size of the window changes. We're going to create that buffer. We're going to draw to that buffer during our game loop. We're just going to keep drawing whatever.
Where's the buffer? Oh, he's going to create it.
Whatever the state of the game is into that buffer. And then anytime Windows needs us to repaint, we're going to blit from that buffer into the window. We're basically going to copy what's in our buffer, or rather we're going to ask Windows to do the copy, since this is the only thing that can actually write to the screen like that. We're going to ask it to copy from our buffer into the space occupied by our window. Now we will also be forcing redraws at, say, 30 frames a second in order to do animation. We will be force splitting, so we will not only be painting inside WM Paint, which is just a message we get when Windows thinks some part of our window is dirty, like it went off the screen and came back, or some other window was obscuring it and went away. So we won't only be painting in Paint, but it's one of the places we'll paint. Okay. How do we do that? Well, you know what? I'm going to make a stub function first. So inside here, in between our begin paint and our end paint, I am going to go ahead and say, like, update window, like this. And actually, that I believe is actually a reserved Windows thing, so I probably can't call it update window. But that's actually okay, because you know what I like to do normally is I actually like to prefix my stuff with Win32 so that the platform layer, so it's clear what is Win32 stuff and what isn't. So that's okay. We'll just call it that, and then our names won't collide with Windows names. Windows has a lot of names to collide with. Okay, so when we basically get our X, Y, width, and height here out of the rectangle that Windows asked us to repaint, we will go ahead and pass them, like this, to our update function. And of course, since now we actually will need the window handle, because we're going to actually blit to the window, we're going to pass it that window handle as well so that it can update it. And then we are going to go ahead and erase this stuff here. So that got rid of our locally persist thing, which, like I said, I don't like and I wanted to get rid of. So we're going to now move this up here into an actual function. The function takes an hwind, right, the window handle. It takes the X and the Y that are going to be the upper corner of that thing. I prefer X, Y, width, and height instead of the top, left, bottom thing. That's just That's just me. So I don't use the naming convention that Windows uses where it's right, left, top, bottom, etc. I use X, Y, width, and height. I just think it's a little clearer for me. It's easier for me to remember. And in here, we are going to update it. So what we actually want to do here is we are just going to call a function that is called, I believe, where is it? Let's see. So dib section. Can we get a dib section? There we go. Guess we should start by creating one. So we are going to have to call create dib section to get it. So we might as well start with that as well. We're going to need create dib section to ask Windows to make us one of these bitmaps. And we are also going to need the function to blit it, what is the best way? There's a couple ways. There's stretch di bits to device, but that actually changes the scale. Which one did I use?
Yeah, I gotta do blit by blit. I think it's too much otherwise. Okay, I think the first one's for my jeez. Resize. What does he do again on resize?
Layer, so it's clear what is Win32 stuff and what isn't. So that's okay. We'll just call it that, and then our names won't collide with Windows names. Windows has a lot of names to collide with. Okay, so when we basically get our X, Y, width, and height here out of the...
Okay, you could update the window. On Paint. Oh, okay, because we... but I don't think we have a Paint. We'll do it outside the... this sort of event loop. What does the resize thing do?
What we're going to do, let me give you the big picture. Basically what we are going to do is we are going to ask Windows at some point, and I'm going to go ahead and just kind of type these out here as functions. We are going to have a function that's basically called resize dib section. And dib section is the name. It's called DIB, device independent bitmap. That is actually the name that Windows uses to talk about things that you can write into as bitmaps that it can then display using GDI. Okay. We are going to have a function that basically resizes a dib section or initializes it if it's never been created before. And basically what we will do is every time we get a WM size message which says that our Windows size has changed, we will basically call that. So we will basically force it to create an entirely new dib section that is the correct size, so it is the size of the entire window. Now, we won't quite, probably, want to do exactly that, because since our game is going to be a 2D game, and we will be wanting to render potentially at fixed resolutions, what we'll eventually probably do is only pick a size that is a reasonable size for our rendering that matches how we have done our source art. That also corresponds to roughly how big the window is, but for now, we can just go ahead and actually create it to be the full window size, and then once our game's render is up and running, we can start to think about those other things and control them. So, what we will do here is we will call resize dib section, and of course what we have to do in that call is we have to basically know what the actual size of the window is that we ended up with after WM size. And the way to do that is a thing called getClientRect. Now getClientRect is a very simple function. If you remember, we had some experience with rect before. It was right here basically. It's a thing which basically says here is a left, a top, a bottom, and a right. It is a lot like something you might see in...
I think you can do this with some attributes. Get window. Okay, I think this one sounds the closest to the window attributes. Display. Okay, try it there. You can get X, Y, width and height. And depth. I don't know what that depth is. But I've noticed you need it when you create a pix map. Which, as far as I understand, is the closest. I think it's the equivalent of bitmap. I am not entirely sure. Maybe they have products, libraries. Reading from display output. Export color is needed to find a core set of primitives for rendering. No. To this one? Maybe it's a bit loud. I do need graphics context. I forgot why. Because there was one of the methods that needed it. Hang on, let me write down what I need to do. So on resize, update, buffer size, and then here equivalent of WM8. Because as far as I understand, there is no paint event. Event. I can check the mask. Can I find... Where did I see the mask? I guess here. Key press, release button, enter, leave. Exposure, visibility. I mean, I don't see anything. Oh, forgot to zoom in as well. Visible. These about the same. Display. Fix map. Fix map. Next create fix map. Of width, height, and depth is specified returns fix map ID that identifies it. It is valid to pass an input only window. I guess you can just reuse this and resize it when the window size changes. The question is, where do you pass fixed map? Put. I did make notes of it yesterday. X create image. Display visual depth format offset data with height bitmap pad. Create image function allocates the memory needed for an XMIT structure for the specified display. Find fuzzy format images only and are derived from visual structure passed in. Excuse me. Some possible hardware may be possible to deal with color resources in more than one way. For example, you may be able to deal screen of either 12 with depth with arbitrary mapping of pixel to color, or 24 with a bits of pixel dedicated to each RGB. These different ways of dealing with visual aspects of the screen are called visuals. There may be a list of valid visual types supported at different depths of the screen. As default, window and visual types are defined for each screen. Most simple applications need not deal with this complexity. Excuse me. I forgot my water. Turn default root window, the depth of the default root window and the default visual type. How do I get... Okay, I think it's just a struct. Can I see the struct? some data, visual ID, class, red mask, green mask, blue mask, bits per RGB, map entries. Then this one is 32, I think. I've seen it in. Saw it somewhere yesterday. I don't know what these masks are and what's a visual ID. Did say you can get it from the root window. Luckily yesterday I did come across yeah, Sizolzing. I don't know how came across this. I mean, I saw the YouTube video a few days ago where he does do the same thing. Downs. He is also using X11 here. If I go all the way down. Yep. X open display. I don't know what this is. Create window. What's a back buffer? Yep, and you can get window attributes because you need it for visuals. For visual. And you can just create an image. What does he use the back buffer for? Put image. Also the back buffer is the drawable. But I guess you can also use window as a drawable. XDBE. No idea. Basically we need create image, create TC, because we need it for the visual. This one we've already done. That's the delete window. Okay, so this is the only thing we need to do. Just gonna ignore the back buffer for now. Then put image. Okay. So we can work backwards, see what's needed for put image. Need display GC X image. I don't know what these are. Source X, source Y, destination X, destination Y. Export image. Display drawable GC and the image itself. Got display drawable can be window, I'm guessing. And we need the rest. Let's get GC first. I did see this yesterday. Excuse me. So you only need to pass in the ones you need. Line width, line style. Yeah, let me check GC. X create GC. Value mask and the values. Okay, that was the struct. Where did it go? What image? Okay, so these are the masks. And then you pass in the values in the struct. Where's my window? Const GC equals dot X create GC. Display drawable. Something and null. This optional GC? No. Okay, we have GC. What else do we need? Image. To combine an image with rectangle of a drawable, use that. This is the bit I don't really understand. Because we need to get some value, which is in memory, or greater values. And that's what's going to be drawn on the screen. Let me have a look again. Yes. Okay, here's the image. Okay, so this is the actual grid. I don't think Casey's got to this point yet. But I think after that, and there's a bunch of shit here. What's the image for? The expert image combines an image with a rectangle of the specified drawable. A section of the image defined by the source x, source y with height arguments is drawn to the specified part of the drawable. If XY bitmap format is used, the depth of the image must be 1, or a bad match error results. The foreground pixel in the GC defines the source for the 1 bits in the image, and the background pixel defines the source of the 0 bits. For XY pixmap and Z pixmap, the depth of the image must match the depth of the drawable. Okay, as far as I understand, we can use Z pixmap, because I did look up, well, I saw one of the videos where it said it was for backplanes. Not really sure what they are. As far as I understand, I think this is the blitting of the screen, or the equivalent of it. Put image. This is where we take our buffer and then put it onto the screen. I think I can look into day 4. Probably make more sense. I could get the window attributes. C.x get window attributes. Text display. Huh. Okay. Window attributes. Window attributes equals undefined. Display window and the struct. Display. And we can use this to create the image. It's the equivalent of getting the rect. Okay, kinda getting some of it. Split image, we need that. We need an image. This is the part that I don't really get. Create image. Obviously I mentioned. We also need a visual. On some display hardware, it may be possible to debug color resources in more than one way. Could ask Cloud. And the X11 X create image method. What is visual? What the graphics context? Xliv uses an opaque visual structure that contains information about possible color mapping. The visual utility functions Use an X visual info structure to return this information to an application. It's me. The members of the structure. What's that word? Pertinent to this discussion are class, red, green, blue mask, bits per RGB and color size map. Okay. I think I did see it somewhere, can't remember. I did the same thing. But he talked about why he kept it 32-bit. Around there. As the visual parameters pointed to a visual structure that describes the visual characteristics of how pixel data should be interpreted and displayed. Default visual. Where's my index? Jeez. Wrong button. Here. Screen number. I'm guessing it's just this. No, default visual display and screen. What was this again? Display visual and a bunch of numbers. I don't know what the rest is. Okay, I think depth is window attribute depth. Yep. Ah, hang on. It also has a visual. Why not just use that one? Format. The format thing is, as far as I understand, yeah, just use this one. Then what else do we need? Offset is 0, because guessing. Pixels to ignore. Don't ignore anything. Data. Image data. So right now, I just leave it. No. Width and height is the window. Yep. And then bitmap pad. This is the bit I don't know. Specifies the quantum of a scan line. In other words, the start of one scan line is separated in client memory from the start of the next scan line by an integer multiple of this many bits. I don't know, 32 sounds pretty good. Let's just put 32 for now. Bytes per line. Number of bytes in the client image between the start of one line and the start of the next. I have no idea. Shouldn't this be like a multiple of the width? I have no idea. Okay, it comes from your data. I think that's as much as you can get from here. But now, I'll just put it at 0. And I'll add it to do add data. And whoa, I think I made a mistake. It's a good thing I didn't close it. Where is it? Okay, this is from your data itself. Okay. Width, height, and yeah, I think I don't need this anymore. Bytes per line. And this will go here. What else does put image need? Source x comma y, destination x comma y. I think source is the data x comma y. I mean, they're both gonna be 0, I guess. You start from the top. And I wonder if this is the width, height of the sub-image which defines the dimensions of the rectangle. What's sub-image? The width. I'll leave it like that for now. So what I still need yep, and on yep, this is what to do as well. Just want to check. Okay. So this also is replace with data with height. Okay, so we're getting somewhere. I mean, I don't think it's gonna work. Create image. CUint. That should work, if I'm not wrong. It's not correct. What does it return? I mean, it says nothing. I guess we can just ignore that. Right now, nothing should happen, but at least that works. Okay, just gonna watch this section
GDI
again,
as little as possible. Basically what
and then
we want it to do is take a bitmap that we have already rendered using our own code and all of our own techniques and just display it to our window. In order to do that, we have to basically ask Windows to allocate a bitmap buffer for us that we can write into, something that's in a format that it is comfortable with us handing back to it. Then we will write into it and tell it to go ahead and display. Now, this involves a bunch of Windows stuff, and I wrote down all of the things that I wanted to remember to tell you, so I'm going to open my notebook here and hope that I don't. They're kind of a little scattershot in the notebook, but hopefully I'll remember them all as we go through it. So, here's what we're going to do. Let me give you the big picture. Basically, what we are going to do is we are going to ask Windows at some point, and I'm going to go ahead and just kind of type these out here as functions. We are going to have a function that's basically called resize div section. And div section is the name. It's called DIB, device independent bitmap. That is actually the name that Windows uses to talk about things that you can write into as bitmaps that it can then display using GDI. Okay. We are going to have a function that basically resizes a div section or initializes it if it's never been created before. And basically what we will do is every time we get a WM size message which says that our Windows size has changed, we will basically call that. So we will basically force it to create an entirely new div section that is the correct size, so it is the size of the entire window. Now, we won't quite, probably, want to do exactly that, because since our game is going to be a 2D game, and we will be wanting to render potentially at fixed resolutions, what we'll eventually probably do is only pick a size that is a reasonable size for our rendering that matches how we have done our source art. That also corresponds to roughly how big the window is, but for now, we can just go ahead and actually create it to be the full window size, and then once our game's renderer is up and running, we can start to think about those other things and control them. So, what we will do here is we will call resize div section, and of course what we have to do in that call is we have to basically know what the actual size of the window is that we ended up with after WM size. And the way to do that is a thing called getClientRect. Now, getClientRect is a very simple function. If you remember, we had some experience with rect before. It was right here, basically. It's a thing which basically says, here is a left, a top, a bottom, and a right. It is a lot like something you might see in HTML, like in CSS. It basically defines a rectangle on the screen. And oops, that's not where I wanted that at all. And basically what we're going to do is we're just going to go ahead and grab the rectangle for our window. And the reason that it's called getClientRect instead of something else like getWindowRect, which also exists, is this just gives us the part of our window that we actually can draw into. Because if you look at a window, so for example, let's say I go take Notepad over here, you can see that the actual part you can draw into is like in here, and then there's this like border frame thing, and that's actually all being handled by Windows, right? So there's not a whole lot we don't want to touch any of that, so we just want to know the size of the part that we can actually draw to, right? And now if we were full screen, when we go, because we're going to want to go full screen eventually, when we're full screen, that doesn't matter because there is no border around the window or anything like that. But until then, when we're using one that has a little border that you can resize, we have to take account for that. Or I should say, take that into account. Grammar. All right, so we are going to ask for the rectangle. You can see it takes an LP rect, and like I said, long pointer to a rect. That's that Hungarian notation coming back there. So we have our window rect, or I should say maybe our client rect, since the window rect is technically something else in Windows. It's the whole window, not just the area you can draw to. I am going to go ahead and get that out, and that will give us, just like we did down here, that will give us our width and our height. So basically we can just subtract the right from the left and the top from the bottom, sorry, the left from the right and the top from the bottom, saying that correctly. We are going to go ahead and do that to produce the width and the height of the buffer that we need to fill the whole window. That's basically how big we will need it to be. So we're going to go ahead and call resize div section, and excuse me, we are going to pass it that width and that height. So in here, we are going to get a width and a height, and we will basically need to build that buffer using Windows to give us a buffer that we can draw into. Then what we will do, once we have our div section sized properly, we will actually in Paint, instead of calling this patblit thing here, which is not really anything that we want to do, we will do the begin paint, and we will use the rectangle that it passes us to basically update that rectangle with whatever the contents of our buffer was. So we're basically going to create a buffer in WM size, because we always get that anytime the size of the window changes. We're going to create that buffer. We're going to draw to that buffer during our game loop. We're just going to keep drawing whatever the state of the game is into that buffer. And then anytime Windows needs us to repaint, we're going to blit from that buffer into the window. We're basically going to copy what's in our buffer, or rather we're going to ask Windows to do the copy, since this is the only thing that can actually write to the screen like that. We're going to ask it to copy from our buffer into the space occupied by our window. Now we will also be forcing redraws at, say, 30 frames a second in order to do animation. We will be force blitting, so we will not only be painting inside WM Paint, which is just a message we get when Windows thinks some part of our window is dirty, like it went off the screen and came back, or some other window was obscuring it and went away. So we won't only be painting in Paint, but it's one of the places we'll paint. Okay. How do we do that? Well, you know what? I'm going to make a stub function first. So inside here, in between our begin paint and our end paint, I am going to go ahead and say, like, update window, like this. And actually, that I believe is actually a reserved Windows thing, so I probably can't call it update.
So my guess is this end paint is the equivalent of code image. Is it? And what's paint? Paint struct.
Window.
I'm not sure.
But that's actually okay, because you know what I like to do normally is I actually like to prefix my stuff with Win32 so that the platform layer, so it's clear what is Win32 stuff and what isn't. So that's okay. We'll just call it that, and then our names won't collide with Windows names. Windows has a lot of names to collide with. Okay, so when we basically get our X, Y, width, and height here out of the rectangle that Windows asked us to repaint, we will go ahead and pass them like this to our update function. And of course, since now we actually will need the window handle, because we're going to actually blit to the window, we're going to pass it that window handle as well so that it can update it. And then we are going to go ahead and erase this stuff here. So that got rid of our locally persist thing, which, like I said, I don't like and I wanted to get rid of. So we're going to now move this up here into an actual function. The function takes an hwind, right, the window handle. It takes the X and the Y that are going to be the upper corner of that thing. I prefer X, Y, width, and height instead of the top, left, bottom thing. That's just me. So I don't use the naming convention that Windows uses, where it's right, left, top, bottom, etc. I use X, Y, width, and height. I just think it's a little clearer for me. It's easier for me to remember. And in here, we are going to update it. So what we actually want to do here is we are just going to call a function that is called, I believe, where is it? Let's see. So Dib section. Can we get a dib section? There we go. Guess we should start by creating one. So we are going to have to call create dib section to get it. So we might as well start with that as well. We're going to need create dib section to ask Windows to make us one of these bitmaps. And we are also going to need the function to blit it, what is the best way? There's a couple ways. There's stretch di bits to device, but that actually changes the scale. Which one did I use? I'm trying to remember which one I normally use. I guess stretch blit would be the right thing to use. So this is a quandary. So this is the one I was thinking of using. Stretch di bits to device. Let's see. Or is it? I guess it's not even to device. I think it's just stretch di bits. Yeah, there it is. Stretch di bits. So this is the one that I was thinking of. And I'll tell you what that one is, and then we can maybe think about whether that's actually what we want. So what this one basically does is this one takes our dib section, the thing that I was saying we're gonna have to create, our device independent bitmap section, and it blits it, but it allows us to scale it at the time. And I was thinking that would be a good idea because then we could always render to the same size, and then we would just, scale it up to the size of the window. And I don't know. So that may be, you know what? I think that's probably what we're going to want to use in the end. So I'm going to just go ahead and use that one now and allow Windows to do scaling in there if we want it to in the future. I'm going to use another kill rectangle if people liked that in the previous stream. Kill rectangle is a fun thing to get rid of those specifiers. Okay. So I'm gonna actually start with that because I think that's what we're gonna want to use in the end, because basically, like I said, if we decide to use a fixed size buffer or a couple different fixed size buffers to do our rendering, and then we want Windows to kind of blow it up to the size of the window or shrink it down to the size of the window, depending on the circumstance, we're gonna need stretch di bits. So I think I'm just gonna go with that. And if it turns out to be a bad call later, we will change it. All right. So all this function does, it's very, very straightforward. It is a rectangle to rectangle copy, and I'm going to explain coordinate systems a little bit later on. But basically for right now, if you can think about two rectangles, we're just going to copy one rectangle to the other. And in this particular case, the rectangles can be different sizes. So we're going to take a rectangle of one size in one buffer and copy it to a rectangle of another size in another buffer, doing scaling along the way if we need to. Oh, you know what? And here's one thing that I forgot. We don't really want the window here, do we? We want that device context, because we already had the device context right here. So rather than having to get the device context from the window, which we could do, let's just go ahead and pass that in there, because that's the thing that we actually have to pass to Windows. So there we go. There's our device context. So we will go ahead and put our device context in there, first parameter. Now we need the destination rectangle. So the destination X, the destination Y, the destination width, and the destination height.
Guess that's the window attribute. And
basically that is some subsection of our window. So we are going to pass it basically the exact things that we got from RC Paint. So basically this is the rectangle that Windows wants us to fill, right? That is the part of the window that needs to get redrawn. So we're going to blit to that, basically, right? Then we basically have our source here. Our source, our X, Y width and height that we are blitting from. And since we are going to start by just making everything exactly the same size, our back buffer will be the same size as our window, this is exactly the same. We are basically having two buffers. One is our window that we're drawing to, and one is the buffer that we are actually drawing our stuff into with our renderer, and we are just going to copy one from the other exactly the same. So then we have to pass basically a pointer to the bits and a pointer to the bitmap info. We have to do some extra stuff here. You don't know what any of these things are yet because we haven't talked about them, and we're going to talk about them in a minute when we actually create the resize div section. But for now, I just want to look at these two additional parameters that control how stretch di bits work. So let's take a look at MSDN again. Go down here. You can see that basically the usage tells you what kind of a picture this is that you have done, what kind of a buffer you have made. There are two kinds of buffers. One is palletized and one is RGB. Now, you all know what RGB colors are probably because you have all seen them before in a paint package or something similar. I'm going to bring up Color Cop, which by the way is a great free utility that everyone should have in their machine. I absolutely love it. But I'm just bringing it up because these little RGB things, or this little guy that you see in Windows all the time, or any kind of color picker like this, just shows an RGB color, which is basically 3 values from 0 to 255 that say how much red, how much green, and how much blue are in a particular color. We'll talk a lot more about colors much later in the series, but for now, you are all very familiar with that. Well, that is what this is. So if you want to make a back buffer that is basically colors specified in that fashion, where every individual pixel has an RGB value, then you want to pass this, and that is what we're going to do. So we are going to put that in there. There we go. Okay, but I will quickly say what this is. What is a palette? A palette is if you would like to be more indirect. So let's say instead you would like to only use, say, 16 colors total. 0, 1, 2, 3, 4, 5, 6, and so on. And so what you want to write into your buffer, for example, are just numbers that correspond to some color, kind of like Pantone matching, or basically some paint chips where you've enabled them 0 through something, in this case 16 bits, so 0 through 65,000. Basically, you then have a palette which is specified in RGB per color, so per index color. So basically it's indirected.
It's why do I mention color? Create image. Blah 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 blah. Not sure. Haven't. Yeah, and I think as you mentioned, I can keep. Where's the width and the height after data? This can be the window width for now, and then height. Oh, actually, the only thing the bitmap has specify the quantum scan line, in other words, start. No, it wasn't it. Is there another 32 somewhere? No, that's the only one. Okay. I'll come back to that later.
One time. So you're basically saying the things that I actually put in this buffer just refer out essentially to another buffer that will tell you what the color is. And this was done back in the day to make things smaller. It's basically a way of compressing the size of the buffer, because since an RGB value is at least 3 8-bit values, one for R, one for G, one for B, that's 24 bits, you could get away with less by using an 8-bit or a 16-bit palletized mode, where you basically just use, say, 8 bits to say what color you're going to do, and then those 8 bits told you to look up in a table of colors that were specified as RGBs. You don't have to worry about that at all, because those days are kind of long gone, although they sometimes come back when you're doing things like texture compression. But fortunately for us, we don't have to deal with that. We can actually do direct RGB writing into our buffer, which is much, much more convenient. So, finally, we have a raster okay. Too sick to talk today. Raster operation code.
Yeah,
and the raster operation code is something that says what kind of bitwise operations you want to do. Now, if you remember from the intro stream, there are a lot of bitwise operations, things like XOR, things like AND, those sorts of stuff. And if we go look where it says they're documented in BitBlit, you can see those here. And basically all this does is it says what to actually do to the destination. Now, all we wanted it to do, we didn't want it to do any fancy bit operations. We just want to basically overwrite the destination with the source. We just want to copy. And so what we're going to do is actually just use source copy, which is defined exactly as that. It is a numerical code that tells StretchBlit to...
So far, Handmade is just pure... Yeah, it's only day 3. Yeah. I think it's only... It does. You can just jump ahead to, I guess, I don't know, somewhere. Well, it's gonna take me like a lot longer to do the same thing because I have no clue how X11 works, so I'm just trying to find the closest translation.
Do go ahead and copy the thing directly. There you go. So that's really all we're going to do with StretchBlit. That will update our window for us. This will get a little more complicated as we start.
Hang on. Is it... What's in the graphics context? Create GC. Join all. There's no mention of RGB anywhere. What is a PixMap? Which they were created. PixMaps are off-screen resources that are used for various operations. Either create a window. No, I don't think it's the same thing. Not even close.
Start to handle other things, but all we really need to do now, if we want to update our window, is we've got to find a place to get these bits and the bitmap info from. And the way we're going to do that is through create div section. This is the part where we actually create the back buffer, because obviously to put that back buffer to the window, we have to actually make it in the first place. And you can see the things that are involved here. First, there is a bitmap info structure, and we'll talk about that, what that is. There is a h-bitmap, which is a handle to a bitmap that it returns to us. So this is actually our bitmap handle that is coming back to us from create div section. Thank you, create div section, for that. We're going to need a device context, but you know what? That device context is not going to come from where you think it's going to come from. It's going to be a little bit bizarre, but we'll get to that. And then we're going to have to look at a couple of these other things here. We have some other things that we've got to specify. So let's go to the MSDN and check out what our options are. Create div section. Okay. Here we go in create div section. We have to get a device context, and I'll talk a little about where we're going to get that in a second. We have to pass a pointer to a bitmap info, and that bitmap info is going to be something that we fill out. So this is an easy thing to do. We'll just go ahead and pass that, and we'll fill this out in a second. There we go. The iUsage parameter. So what is iUsage? Again, this is the exact same thing that's asking us. When we created it, wants to know, is it going to be palletized or is it going to be RGB? And since we're blitting in RGB, we used RGB in StretchBlit, we need to use RGB here as well, because that is what we wanted, right? Then we have a pointer to the bits. And so this is actually the big moment. This is the actual memory, this is the bitmap memory, that we are going to receive back from Windows that we can finally draw into with our own renderer. That is the big thing that we wanted. That's what we really wanted out of this whole platform layer, and that's what we're about to get finally, after 2 days. So, the
hang on, it's put image. X image, yeah. So this is where my guess is the data we need to put. What is this type? Pointer to image data. Oh, I totally missed the rest of it. Red mask, green mask, blue mask. Oh, I think I used it from create image. I think we use the visual for that. Yeah, so it uses whatever the default one is. Where's data? Okay, it's just a slice of bytes. I mean, that's fine. Okay. An image with a rectangle of drawable on the display. Good image. Right. That's like the update display. Okay, I mean, I'm still a bit confused. I'm less confused than before.
H section, excuse me, is basically something that's used if you want to do something fancy with your div section. That's sort of doing it out of core and writing it into, I guess, into a file or something like this. We don't care about any about this stuff. We just want to allocate one in memory for us. We don't want it to back it with a file or do any of this stuff. I don't actually know if it does back with a file. It may just actually use some kind of memory mapping for it. I don't know. I've never actually used this parameter, so I don't care at all about that. And we're not even going to spend any time on it because time is of the essence here on this stream. And finally, we have an offset, which is referencing this thing. So since we know that we're not passing this thing, and it's ignored if this is null, we can ignore that as well. So there is our create div section call. It will create the div section for us, and pretty much that does everything we want it to do, except we did not fill out the bitmap info that we are passing to it. So what on earth is a bitmap info? Again, this is all the vagaries of programming on Windows. It's a bit esoteric, and I don't blame you for going, what on earth is going on here?
He says that because he hasn't seen the X11 doc yet. I don't know. I don't think it could be worse, but it might actually be worse than the Windows API.
It's just the way it goes. Here we are in the bitmap info. So, we have a bitmap info header. It's called .bmi header, and we have an RGB quad, which is BMI colors.
But also, to be fair to X11, it's also really old, so I guess.
Now, this is a little syntax that's used in old school C, and then basically, if you define an array at the end of something, it allows you to make it variable length. You can basically keep on going off the end of this thing, accessor-wise. I'm not even going to begin to talk about that and how that works or anything like that, because we don't care about that right now, and I don't think you should really, I don't really recommend ever doing it either, but if you really care about it sometime in a Q&A, I will tell you what's going on there, because it's super janky and weird, but it works if you think about it. Anyway, we don't care about this because we are not using a palletized buffer. Like I said before, we are using RGB values, and we'll see how those work in just a little bit. Probably tomorrow's stream will be a lot about that. But anyway, this is basically where the palette goes. It's a variably sized array that will contain all of the colors that you plan to reference in your buffer. And since we don't plan to reference any colors, we plan to write the colors directly into the pixels where they belong. We don't have to worry about that at all. So BMI header is really the only thing that we need to know about, and because we are going to have to fill that out in order to specify what we want. So in here, you will see all of the things we have to specify. So BI size, it says the number of bytes required by the structure. So that's basically Windows asking us to put into the structure itself how big the structure actually is. Now that makes some sense probably, because maybe they want us to include like this if we had one of them or whatever. Sometimes Windows just wants you to pass the size of things so they can tell what version of the API it was that called them. But basically, what we need to do here is use that size of function that we saw before, where we can get the size of things. We saw that in the intro stream, to basically just find out the size of the structure itself. So hey, whatever the bitmap info structure is. Now, do they want the size? Which do they want the size of, ladies and gentlemen? Do they want the size of this, or do they want the size of this? That's the real question. Number of bytes required by the structure. It doesn't say. And An application should use information stored in the BI size manager to locate the color table in a bitmap as structure. Oh, here is the clue we needed. It says the color table, which is I believe this right here. It says the color table is the thing that comes the BI size. Yes, BI size after. So this is exactly what we want. Okay, so if you were in the intro stream, you remember us doing something exactly like this. We basically took a pointer we cast it to a char star, which is exactly what they're doing here. That is Windows pound define for a char star. We casted a pointer to a char star, and we added a memory offset to it to get to a new place in memory. People who remember the stuff from the intro stream, you are very happy right now because that is exactly what you need to know. So now we know what that size parameter actually is. The size parameter is how big the header is so it can skip to the color table, which to me suggests that it should only be this size. It should only be this thing here, and it should not include the color table. So we're going to go ahead and use just the size of the header portion like that. Next field we need is the width. We know what the width is because that is getting called right here. We know what the height is, so that is right there. We know what the planes are because that is sort of that is an old school notion. Basically, bit planes used to be when you would specify multiple chunks of memory that get combined to give you the color. We don't have to do that anymore. Thankfully, all of the pixel RGB values are not stored in like a red plane, a green plane, a blue plane, or something where you have 1 bit per each.
The equivalent of that in Linux is the pixmap thing. Yeah, so that's one thing I did notice somewhere. When you create an image, you pass in the format. As far as I understand, the XY, bitmap and pixmap is what you said when you're working with bit planes. That's why you can just use Z plane or the Z pixmap. That's the one thing I remember.
Part of the red value or anything like that. We don't have to worry about that, thankfully. Everything is actually per pixel packed together nowadays, and you can't even specify anything other than 1, apparently. It says this value must be set to 1. So we don't have to worry about that. We don't have planes, we only just have our back buffer, so that's good. We'll talk a little bit more about these things when we decompress. Maybe on the Friday stream, when we go back over everything, I will talk a little bit about the history of some of those things for everyone. But for now, I want to keep going. The bit count is the number of...
Yeah, I know, but I don't know if you've... you know when you go out with your friends for a drink, next time you go out, you should notice. Like when your friend takes a sip of his drink, or like whoever's near you, and you tend to do the same thing. It's weird. Yeah, I'm not trying to. It's just, yeah. Next time you're out for a drink, notice.
Bits per pixel. Now, 24 is actually how many we need, but I'm going to ask for 32 for reasons that will become clear in a little later. The reason I say 24 is because we need 8 bits for red, 8 bits for green, 8 bits for blue, just like you would see in, say, HTML or something like that. We want an 8-bit color for each for now. And I'm going to actually ask for 32 because I want things to be D-word aligned, but you don't have to worry.
That does... Okay, that seems a lot similar to the create image. So when you resize, I need to recreate the image based on the window size. Okay.
About that just yet because we're going to talk about alignment totally separately. All right. And that will involve us opening up the Intel architecture manual, which is always fun, ladies and gentlemen. You will enjoy it, I promise you. So we can then say what kind of compression we want, and we do not want this compressed at all because what we want to do is be able to write to it as fast as possible and blip from it as fast as possible. We do not want it to be doing any fancy compression, so it's going to be thinking about things at all, trying to compress them. We do not want that. So we're just going to pass BIRGB for...
I'll be right back. I'm out of coffee. Okay, let's go.
For the format, sorry, what was the actual format name? It is BI compression. BI compression. There we go. Size image. What on earth is that? The size in bytes of the image. This may set to be, oh yes, to be 0. So
Hang on, I think I kind of understand now. A little bit. So when I resize, what data is just... Whoa, what's this? Oh, that's the build. I could have a method. Update window. No, resize window. I just call it resize. Need display and window. Yeah. I should return c.x image. Yep. I think it's a C pointer to... Hang on, don't remember. Oh yeah. Struct underscore x display. No. Check here. Optional point to the display. And then window. It's just window. X window. Why is it going there? I can go down. Where's my... Yep. Get window attributes. Get image. Data is null. I go, where's data? Not sure. It's a C pointer. Slice of C pointer to a U8. So it's basically a slice of bytes. We don't know how big it is. Can I do width times height to U8? And I can do 0, which should be... Oh no, I can put it all white. Unless it's RGB, then it's... Let's try that. WA dot width times height. And then I can do sort of null. Data. Why did it say 1? Oh no. Oh no, it's correct. I guess. So I get the existing square and then just print it right back. But I set the data to be black. Not sure. Let me try it. Resize. Display, comma, window. I think I don't need these. I can just get it from okay, something should happen. Oh yeah. It's not com time known. Get a variable. Yeah, because it is runtime. Alright, bossy. You take care too. Have a good one. Let me make this now, see what happens. Copy that and put it here. Hang on, I gotta use that image though. Get rid of this. Expected. Okay, it's a pointer. I mean, now if I resize, something should have. Fuck. Okay. Fatal IO error, bad address. I don't know what happened, but the only thing I can think of is that data is null. Yeah, could be that. But as cloud. How can I make this runtime only? Okay, I know. Const buffer is I could just create it really big. What's the max? What would happen? It should just turn to null. Yeah, I'll just put 8,000. Shouldn't go past that. It'll actually make it all 0. Will this work? No. Let me simplify it for now, and then just here, instead of null, this will be buffer 0 to width times height. was the other? Expected indexable found comp time int. How do you set it to? As far as I remember, that's correct. Oh, okay. Let's see. Expected type. Okay. Expected C pointer. Yeah, I did. Do I have to like cast it? Data. C pointer. You wait. To cast. Buffer. Check the doc. C pointers. Blah 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 blah. Type is avoided whenever possible. Yep. Yep. Suppose all syntax. Suppose type coercion. Will this work? Well, let's try. Nah. How can I convert price of const u8 to C pointer is const cast of slice the pointer. I mean, that doesn't look right either. Oh no, I got rid of the size. Okay, I didn't expect that to work. Okay, damn, can't believe that worked. But I don't think it did. I think it was supposed to be all white pixels. Unless the data is not right. Foot image, create image, pointer to image data. What was that black pixel? If it is RGB, zero, put FFF, and it's 32 bits, I guess. Would that work? Yeah, it's too big. I think that might be too big too. That's just one now, but it shouldn't. Whoa. And now it doesn't do anything. The original data stays the same. Okay, I mean, I can figure that out. That's not a big deal.
Basically, that's just going to that is just going to show up if you actually have a compression format where Windows wouldn't know how big the thing was going to be because you were going to do some compression on it. Pels per meter is sort of totally useless for us. Why would we need to know that at all? That is something is only if you were actually using some kind of print output. Pixels per meter, we don't even have anything about that. So can we set those to 0, ladies and gentlemen? Is there a way to set those to 0? I feel like they could both be set to 0, so I'm going to set them to 0 for now.
I know. Let me ask. Using export image, how can I set data to be black pixels? Put a pixel. X image, XY, and pixel. Okay, could try that. Let's say X, Y. Dot export pixel image 0,0 and pixel. Guess one should be black, white. Put it down and why can't I find it? CW black pixel. White back. So how come still a lot of gaps in my understanding of X11. That's not defined. Guess it's gonna fail. Yeah. Maybe it's in X utility. Something like that. X11 utils. Let's see, it's somewhere. It's 11 handbook. No. X utils. I just gotta basically guess. Okay, no. But I got lucky. Okay. That one's... what happens if I try and build it? Basically, if I set data to 1 or 0, should change the like pixel. But it does not seem to be the case. No. Alright, let's carry on for now. I could check. What's that project called? It's 11 double buffering. Just put image, create, red pixels. What is R? Nah, then I gotta look into the grid. I guess let's. Oh, I
hoping
just
that
have
it
to
does
be
not
patient.
mind, because that is basically for printing and that sort of stuff, where you have an actual, or something where you actually care about the physical size. We don't even know what the sizes of our display at this point, so we're in no position to say how many pixels per meter there are on it, because we don't know anything about that. Clear used, the number of color indexes. Okay, this is how many colors are used in the color table. I just said we don't have a color table, so we don't care about that at all either. And finally, BI color important, also not care about, because we do not have any of that index palette stuff. Okay, this should actually go through and allocate our bitmap memory for us, but we will not know until we actually try if we've done everything right. But I want to point out something that we now need to handle, and that is we actually need to free, well, we need to get our device context first, so we need to do that too, but we actually need to free this thing before we create a new one, because like I said before, if you go down here and you look at the WM size command, you will note that we basically have a resize deep section call will happen every time we WM size. So if we allocated new memory for our buffer every time, that would be bad. So what we actually want to do is just right before we create our new dib section, we could free the old dib section, or we can wait and see if we can get our new one first, and if we can't, we can keep using our old one. It's a tough decision. It is a tough decision, ladies and gentlemen, because basically there's a bunch of trade-offs either way, depending on how we do it. I am going to go ahead and say what we will actually do is we will actually free after. We'll create ours first and then free after. The reason that's a little touchy is because if we needed the memory from the first one in order to get the memory from the second one, because it was occupying too much memory, we would be kind of shooting ourselves in the foot. So maybe the other thing we could do is if it fails, yeah, this is hard. So you know what? We're going to put to do here, and we're going to say bulletproof this, and we're actually going to just do a free, straight up free first. So basically what we'll say is bulletproof this, maybe don't free first, free after, then free first if that fails. Maybe we'll give that a shot a little bit later just to be a little more resilient depending on these circumstances. Okay, so what we're going to do here is basically right here we will free it, free our dib section, but then down here we will create a new one that we can then use to draw. So we're going to have to remember a couple things. As we can see down here, we need that bitmap info, which is this thing, right? So this guy is going to have to be persistent. So let's go ahead and put him out here, right? He's going to have to stick around forever. There you go. And now that will also clear him to 0. So that means all of these guys are cleared for us for free, right? Don't actually need to do any of that. Cleared for us for free out in the bitmap info. Then we've also got this bitmap memory right here, which is void star. And again, these global variables will probably not last long. We are going to make them unglobal in just a little bit. But for now, to keep things simple and to make sure that we are on time for the day, we are going to go ahead and use them because they are going to use sort of across multiple things that do not share a context that we can easily get to. But I'll show you a little trick for that a little bit later. And then finally, we are going to probably need that bitmap handle, because without that bitmap handle, we would not be able to free it. So I'm going to store this as well. So there we go. And what I am going to do is I am going to say bitmap handle global variable. There we go. I am going to say at the top of this, if we want to free our dib section, basically what we're going to have to do is if we actually have our bitmap info initialized. And since this is the first thing we initialize, I'm going to go ahead and switch on that. I'm going to say if that's actually initialized, then we assume that we will have to actually get rid of this stuff. I don't know if bitmap handle actually is something I can test for as well. Let's take a look at that. What is that actually defined to be inside Windows? I don't know if that's the thing we can test on. Let's take a look. Bitmap, hbitmap. Type def, it is a handle. So I don't know if that'll come back as invalid handle value or what. That is a good question. Let's take a look at create dib section and see what it says the return value is on failure, because I don't actually remember.
Hang on. Now I'm a bit impatient. Must be somewhere here. Concepts. Nothing. Get image output. Find rendering options, blah blah. Don't need that yet. Graphics, context, colors, sync-in and flash-in, which is accept. Region onto which drawing can occur. Like Windows, pixmaps are now part of a hierarchy. Oh yeah, I did read about this. It's just another rectangle. Right now we're drawing straight onto the window, but it's also a drawable, but I guess you can also use pixmaps. What is a pixmap? Recently access pixmap, faster access video RAM using shared memory, can push updates faster, not yet. Syncing grabs. Same one. Can't find the doc I was looking into a few days ago. No, it wasn't that book. No, not this either. Into information, display functions. Connect, obtain information, close. Window functions. Done this. Create and free pixmaps. A bitmap is a single plane pixmap. What does that mean? Create pixmap of a group given size. Use display, drawable, can be window, width, height, and depth. Within the specified returns pixmap ID that identifies it. It is valid to pass an input-only window to the drawable argument. The width and the height arguments must be non-zero. No, because we do need to use a bitmap. Bitmap is a single plane pixmap. Single bit plane pixmap. I didn't know what that means. No. Graphics. Transfer images. Xlib provides function that you can use to transfer images between a client and a server. Because the server may require diverse data formats, Xlib provides an image object that fully describes the data in memory and that provides for basic operation on that data. We should reference the data through image object rather than referencing data. Okay, directly. Okay. Can use data formats by replacing functions in the procedure vector with the special case functions. Supported operations include destroying the image, getting a pixel, storing a pixel, extracting a sub-image on an image, and adding constant to an image. See section manipulating images. Several functions, basic operation on images. All operations on image are defined using ximage. Because the number of different types of image formats can be large, this hides details of image store properly from applications. Provide fast implementation. Okay. That no, we don't care about reading from disk. Client's memory. The user can request some of the members such as height, width and X offset change when the image is sent to the server. Note that bytes per line in concert with offset can be used to extract a subset of the image. Other members, for example, byte order, bitmap, bitmap unit, and so forth, are characteristics of both the image and the server. Between the image and the server makes appropriate conversions. The first byte of the first line of a plane N must be located at the address. Interesting. First byte of the first line. Data times height times bytes per line. N times height times, what is N? Total number of pixels? I mean, if it's all one, should it matter? First byte of the first line of a plane. Ah, gotcha. So, okay. First line, okay. Because each line is however long. Yep. Okay, I was reading too much. Transferring images between client and server. Yep, that's what I'm using. Basic functions used to get a pixel, set a pixel, create, blah blah blah, defined in the image object. To set a pixel, yeah, this is the one I couldn't find. Where is this defined? So I wanted to look into this. Xlib provides functions that you can use to transfer images between a client and the server. Because the server may require diverse data formats, Xlib provides an image object that fully describes think I read this already. I don't know, kind of stuck. I know I'm jumping ahead. Cause... Alright, fuck it. Just continue.
There it is. Takes a little while in MSDN sometime. Okay, let's see. Return value succeeds. The return value handles. If the function fails, return value is null. Okay. So basically, this will initialize.
I think I can go to day 4. Device context. Sounds like graphics context. We've already got it. Okay, I'm gonna go to day 4.
Start recording. Okay, hello everybody. Welcome to day 4 of Handmade Hero. This is sort of day 2 of my sickness stream, so I apologize for my scatterbrainness, although let's be honest, I'm kind of scatterbrained normally. Last night was a bit of a defeat for us because we were just about to draw stuff to the screen and we didn't quite get to it. I elected to not push into the Q&A and take time away from that. I decided to go into the Q&A as we normally do, but tonight we are definitely going to start drawing stuff, but we are going to start with a very important correction, and I am very happy that that Chris Hecker tweeted at me because this is a good thing. I'm going to go ahead and launch our editor here and bring up our source code that we were working on, because after Chris tweeted at me, I realized what my confusion was yesterday, because I was a little confused, and I think you could tell in the stream I was a little hesitant. When I came in here to write Win32 update window, I said something like, should I use stretch to bits or shouldn't I use stretch to bits? I was kind of hemming and hawing. What I didn't actually fully explain at that time is the thing that I was actually thinking of using instead of stretch to bits, and what that was bitblit. And bitblit is the function that I normally use. I never actually use stretch to bits. I mean, I'm aware of it and I know what it does, but I never actually use it. I normally use bitblit. And so the thing that was causing the problem yesterday, and this is a bit of a bummer that I just didn't think of it, was that actually that is why there was the confusion about whether we needed to create a compatible DC. You remember S. Sylvan wrote in very helpfully to point out the fact that since stretch to bits takes a pointer to the bits, why do we even have to have Windows do this allocation stuff for us? And I was like, gosh, I don't know. And in my mind, I was thinking, well, I'm pretty sure you need to do it for performance reasons, but why was I thinking that? Because I don't normally call stretch to bits, but I just thought that that was true and blah, blah, blah. Well, the reason is actually because this is what I normally use. Bitblit is what I normally use. And if you notice, bitblit does not take a pointer to the bits. It has to go device context to device context. So what I was thinking in my head is I was thinking about the stuff you had to do to use bitblit, which involves creating a DC that you leave around that has the bitmap in it, and that you always do the bitblit from that DC to the screen, to the window DC that you're actually drawing to. That's what has to happen. So you have to do all this stuff because you can't pass a pointer to the bits. But if you call stretch DI bits, which I never do, you can actually just pass a bit pointer, which means you don't even need a DC or a bitmap. So the question is, why do I always use bitblit? Well, the reason, and this is why Chris's tweet jogged my memory, because he actually...
Hey Kamigoroshi. I'm just... What am I doing? Good question. Oh yeah, I'm trying to follow Handmade Hero, which is built in Windows. I'm trying to do it in Linux with SIG. Is that something programming? Yeah, it is.
He's a pro at this stuff. I mean, he knows this stuff better than anyone probably in the world, because he wrote WinG, which was actually the first way that you could do this sort of stuff on Windows. It was under Win3.1, Win351, or Windows for Workgroups, whatever it was, Win3.1. You could actually do these blitz to make games actually run on Windows way back before they could. And so he knew all about blitting on Windows, and he just knows that cold. And what he pointed out was stretch DI bits used to be the slow path. It was slower than bitblit because bitblit, since Windows could do the allocation of the memory and had the bitmap already selected, it was a faster path than going through stretch DI bits, which is why I've always anachronistically used bitblit. But since this is supposed to be for us to learn to write a renderer, and that performance difference may not even exist anymore. This was back when things weren't going through a 3D card under the hood and all these sorts of things. There's probably no reason for me to ever use BitBlit. StretchBlit is probably going to be fine for us, because eventually what we'll do when we optimize things, we'll want to create an OpenGL context and actually write directly to a texture with overlap downloads and these sorts of things. So when we get to like the sort of, okay, we wrote everything ourselves and now we're going to start doing hardware things or whatever, we're going to want to do something different anyway. So really we can just use StretchDI bits, and I do not have to worry about the thing I was worried about, which S. Sylvan also was pointing out we shouldn't need to do. And he's right. I don't think we do need to do that. So with that correction in place, we can actually simplify things quite a bit. What that means is we don't actually need to store any of this stuff anymore. The HBitmap and the HDC that Windows was going to create for us, we don't actually need those anymore, right? We don't need the bitmap handle. We don't need the device context. So all we actually need to do is have this bitmap info.
Not at the moment, no, because I mostly do this for fun. It's like, when I stream, I tend to follow through with my side projects. That's the only reason to do it. But thank you though.
Header filled out that has the width and the height correct, right? And then we can allocate the memory by ourselves. We can just allocate our own memory however we want to. And as long as it is the right size and works okay, Windows will go ahead and do the right thing. So that makes it a lot easier for us, and that's what we're going to do. So we're going to keep our bitmap memory here, but what we're going to do instead is we're going to go ahead and say, note, thank you to Chris Hecker of Spy Party fame for clarifying the deal with stretch dibits and bitblit. No more DC for us. So this is awesome. So basically what we'll be able to do here is we'll basically just say, we need some memory. Windows, we need some memory for our bit.
Oh, I don't think I have time to do like professional YouTube. Plus, I mean, I don't think I'm that much interested. I work as a programmer. Kami
Map. And the first question is, how much memory
does that mean? God Koroshi. I think Kami means God, right?
do we need? Well, we have asked for 32 bits per pixel. 8 bits red, 8 bits green, 8 bits blue, and I am going to leave a padding bit in there. Padding byte in there. So 8 bits of pad. And the reason that I'm going to do that is because, in general, on the x86 architecture, oftentimes there is a penalty for doing what's called unaligned accessing. So basically, if you are trying to operate on a value that's, say, 8 bits, 16 bits, 32 bits, 64 bits, this sort of thing, if you're operating on like 32-bit values, 32-bit values should be aligned on 32-bit boundaries, meaning they should be on like the 0th byte, the 4th byte, the 8th byte, and so on. They should not start on like the 2nd byte. They should always, if they're 4 bytes long, they should be at multiples of 4 in memory. And that's just the way the CPU is set up to deal with them. And so what I want to do is I want to make sure that whenever we touch a pixel,
Thank you.
just for now, especially to simplify things and to make sure we're not incurring any penalties unnecessarily here, just to simplify things, I want to make sure that we're always touching a pixel on an exact
So I'm from India.
4-byte boundary there. So if we were to ask for the bits that we actually need for RGB, that would be 8 bits, 8 bits, 8 bits, or 24 bits. And 24 bits is 3 bytes, which is in no way aligned with 4. You basically have to go out 3 times 4, or 12, to get back to the right boundary, right? So that's not going to do it. So I'm asking for 8 extra bits that I need, and those extra bits are just going to be padding. They don't actually mean anything, and they won't actually be used, but we're just going to do that so that we know that our pixels are always aligned on 4-byte boundaries. So if that is the case, then I know I have a pixel size of 4 bytes, right? That is how big that's going to be.
Yep. Aha. Okay. Because here, X create image was the. Excuse me. Where's X create? I can't find this. In one of these. I work as a programmer. Let's create image. Bitmap add. Specifies the quantum of a scan line. In other words, start of one scan line is separated in... Oh. This... What if there's no pad? By an integer multiple of this many bits. Quantum of a scan line. In other words, the start of one scan line. That would mean one line would only be 32 bits. Client memory from the start of the next scan line. Bytes per line. No, that doesn't make any sense. That's not what I thought. Never mind.
So I need
thank you, but no, at the moment I don't need it. Cheers though. I mean, if you want to become a programmer, there's plenty of free resources. You should try, what's it called? Code 3. It's pretty good. Or boot.dev. This one's good too.
enough of these 4-byte pixels to have the width times the height.
Oh, or you could try Handmade here.
Worth of pixels, right? Because this is sort of elementary math. If you have a rectangle and you want the area of that rectangle, you multiply the width times the height, right? And so what we want to know is how many pixels do we have? Well, we have width times height pixels, right? But each pixel is 4. So if I was to make this a little more explicit, I might say bytes. When you want worth height, pixels are always aligned on 4-byte boundaries. So if that is the case, then I know I have a pixel size of 4 bytes. Right, that is how big that's going to be. So I need enough of these 4-byte pixels to have the width times the height worth of pixels, right? Because this is sort of elementary math. If you have a rectangle and you want the area of that rectangle, you multiply the width times the height, right? And so what we want to know is how many pixels do we have? Well, we have width times height pixels, right? But each pixel is 4. So if I was to make this a little more explicit, I might say bytes per pixel equals 4, and say that we have width times height times byte per pixel, right? So this is the size of our bitmap memory, right? And if we want to allocate it, we say the bitmap memory equals something that allocates bitmap memory size worth. Now, in Windows, how can we allocate something? Well, I like to use virtual alloc for a couple reasons. We could also use heap alloc. Either way, we are probably going to stick with virtual alloc mostly, so I might as well go and introduce it here. Basically what this does is it goes ahead and allocates a certain number of memory pages. And basically what happens is when you allocate memory directly from the system, it is generally allocated in pages, and pages are a certain size. In Windows, they are often 4096 bytes, sometimes they are 64K. It depends whether they're large pages or small pages. That's sort of an operating system thing that we'll talk about a little bit later potentially. But basically, there's two ways we could allocate memory. We could allocate it with heap alloc, like I mentioned, and heap alloc is basically asking the system to sort of sub-allocate out of the pages for you. So you can pass any size you want here, and you will get back a pointer to that. Whereas virtual alloc is a little more raw. Virtual alloc must give you back pages. So you can't, for example, ask for something that is less than 4096 bytes and expect it to give it back to you. What it actually will do is it will give you back the whole 4096 bytes, and the rest will just be wasted. I want to get you used to allocating memory from this because we are going to be doing almost all of our own, we're going to be doing our memory allocation almost entirely ourselves in this project. So I just want to get started with this virtual alloc right away so you're used to calling it and it does not frighten you. So I'm going to call virtual alloc, and I'm going to look at the things here. We are going to virtual alloc our bitmap, and we are going to take a look, and it says it wants the starting address of the region. Now this would be good if we actually wanted to place our, because remember, we have a virtual memory space. For those of you who watch the intro stream know, every process in Windows has a virtual memory space, its own addressing scheme for memory, and that gets, moved out to physical memory depending on the how the operating system chooses to map it. But we are always looking at basically a nice big flat 64-bit address space that appears to all be our own, even though Windows behind the scenes is sort of swapping that in and out of physical memory, putting it to disk, doing whatever it needs to do to make it appear that way to us. But as far as we're concerned, we have a nice big flat address space. And as long as we don't use too much memory, we can kind of assume that we'll all be actually put in physical memory, so we won't have to incur any kind of weird performance penalty. So, all we have to do here is say we don't actually care where the memory is, because we don't have any real restriction on where it is. We have to say the size, and this is the size of the region in bytes. Basically, if the address parameter is null, the value is rounded up to the, why is this scrolling? There we go. Rounded up to the next page boundary. So since we did pass in the LP address as null, it means that even if we pass something that is less than even multiple of the page size of the system, it will just round it up for us, which is exactly what we want it to do. So that's totally fine. Then, we have the allocation type, and that is going to tell Windows what we actually want it to do to this memory range. And the interesting thing about this is there's two actual things it can do. There's commit and reserve. And what's interesting about that is basically, since it is a virtual memory space, what that means is you start off with 64 bits of address space, but basically all of it is essentially vacant. It's not actually memory yet. And you basically have to say, okay, I'm announcing that these pages are actually now going to be used by me, so Windows can know, oh, okay, he's actually going to use some of this memory space. I have to start tracking it and working with it, putting it in physical memory, doing whatever I need to do with it. And it has a little page table basically that it keeps that says which pages for each process are actually being used. Now, what that means is when we go through virtual alloc, there's two ways we can ask for memory. We can ask it to actually start tracking the memory, and we're actually going to start using that memory, that's what commit actually is. But reserve.
I'm going to continue tomorrow. Excuse me, because I got to go to the gym. But I do want to find that documentation. Where is the X11? Where can I find? Oops. I can't remember the link. I don't think it's, no, not this one. Oh yeah, oh no. For a second I was like, I thought I found it. Not this one either. Right, anyway, because I mean, this does make sense, because right now I'm just using an array. I can get rid of this and allocate something too. Virtual alloc. Sick. What's the closest? Page allocator. Can I just use an arena allocator in the beginning? Allocating memory, something like that. Or memory allocation. What was it called? Allocating. Oh yeah, it's here. Choosing an allocator. Making a library? No. Are you linking to libc? Yeah. Heap.c allocator. Kinda. Maximum number of bytes you need bounded by a number known as count time. I mean, the rectangle's always gonna be the same. Or the buffer, for instance. Unless someone resizes. Even then, because you want a fixed bound. Command line application. Cyclical patterns such as a video game main loop. And such that it would make sense to free everything at once at the end. Yeah, I could use an arena allocator. I do find it quite easy. Yep. Also, if the upper bound of memory, yeah, I think I could later change to fixed buffer. I could start off with an arena allocator. Alright, before I continue with day 4, there's a few things to do. I duck on creating image, then sample data format, adding pixels, no, not adding, setting pixel size, no pixel, data size. Yeah, I'll check this first thing tomorrow before I continue. It just makes sense. I'm gonna try and find the dock. That looks cool. Oh, this is what I need. Okay, I'll leave this open. Okay, I'll leave this open. I think this could work. Doing one of these examples should find what I need. Don't need this. Don't need that. Don't need that either. Okay, I'm gonna call it a day. Yeah, that's quite late. Gotta go. Alright, have a good day. Thank you for hanging out. Hopefully, one of these days, I can figure the X11 library. Right now, it's all... I'm still a bit confused about... Not confused, like I just don't know how to... put an image, or like what the image should be. But apart from that, some of it kind of understand. Alright, see ya. Have a good rest of the day.